In this video, we're going to go over an example of a mixture problem, and that's just one of four different types of problems in section 1.2. So what is a mixture problem? Well, a mixture problem has something to do with this question: how chocolatey do you like your chocolate milk? Now, I'm not the type of person that buys a gallon of chocolate milk out of the dairy case. I will buy my Nestle Quick or maybe Hershey syrup to put in my milk, and I stir it up. Now, my husband likes a lot of chocolate in his chocolate milk. I like a little bit of chocolate in my chocolate milk. So the concentration of chocolate varies in our chocolate milk. And that's kind of what we're talking about in these mixture problems. So in this example, we have this woman who's a chemist, and she needs a 20% solution of alcohol. So in my chocolate milk example, we're talking about having 20% chocolate and 80% milk. Well, she needs 20% alcohol and 80% something else. Now what she has is 15%. She also has a 30% solution. So she's going to mix those two together in such a way that she gets a 20% solution. So in terms of chocolate milk, I have not very chocolatey along with super chocolatey. I'm going to mix them together to dilute the super chocolatey into something that we can drink. That's kind of what's going on here. So we want to know how many liters of the 15% solution she needs to add to 3 liters of the 30% solution to get her 20% solution. So in pictures, here's what we have. We've got 15% solution, but we don't know how many liters we have. So X liters is what we have. We're going to add that to 3 liters of our 30% solution. And what we're going to get is a 20% solution. But the best that we can do to describe how much we have is X plus 3 liters. Now, another way to set this picture up to organize our information is in a chart. In this chart, we've got a column to describe our concentration, our percentage, although notice that I'm using decimal values here. I've got the number of liters, so X liters, 3 liters, and X plus 3 liters. And then over here, not just liters, but how much of what I have is pure alcohol. Well, since it would be 15% of how much I have, I'm going to multiply that. And that's why I would use the decimals. Now, I do have a method, the way I set these rows up. If I take the smallest amount and combine it with the biggest amount, what I'm going to get is somewhere in the middle. And that's how these problems are typically set up. You take the smallest concentration, the smallest percentage, combine it with the biggest percentage to get something in the middle. So I've got a 20% solution that I want. If we look back up here to our jars, we see we have X plus 3. Now notice I can also add these two boxes here. And then I multiply across to get an algebraic description of the liters of pure alcohol that I have. Now the equation itself comes from taking the liters of pure alcohol from the smallest amount plus the liters of pure alcohol from the largest concentration, and we set it equal to the liters of alcohol of that middle concentration. Some people try to remember it as small plus big equals middle. So over here, we're solving it, and what we end up with is 6. Now go back over to this chart and we can figure out what X stands for. X is the number of liters of our smallest amount. So we need 6 liters of the 15%, which is what they were asking us for. So at this point, we're done.